guys, R is 0.0675 over n, which is 2. Then we raise that to the n times t power. And I'm just getting this from up here, okay? It's not like you have to have this memorized. You need to have it written down on your cheat sheet. Don't come up during the test and say, what's the formula for compound interest? So it's going to be 2 times t. Okay? Now it says, what's our balance after 20 years? So now we're going to fill in the rest of the values. 300, 1 plus 0.0675 over 2 times 2 times 20. Now, I do recommend, because this gets a little funky when you're plugging it in, to simplify first. So I do 300, just ignore those words, 1 plus, and I actually do that division, 0.0675 divided by 2. So that's 0.03375, and 2 times 20 is 40. Now I plug it into my calculator. And I do that on purpose because there's too many keystrokes and too many places you could mess up on the calculator. So I always do that, a little bit of simplification first. So then 300 parenthesis 1 plus 0.03375, close parenthesis raised to the 40th equals, A equals, and I'll have to erase this, so make sure you write this down because we got to do the other problem. 1131.73. We're talking about money. It was compounded semi-annually. This was 20 years, so we took $300, and now it's worth $1,131.73. I'll leave that for a minute. Pause your video. Write that all down. If you got as far as here, and you put everything in correctly, and then you're getting the wrong answer, it's calculator issues. So I would do the simplifying first, and then do the whole rest of it. If you're still having trouble, come see one of us and leave what you did in your calculator, because that'll help us see what keystrokes you're making a mistake on it, okay? A lot of people think, oh, I need to erase this. I don't want anybody to see my mistakes. That's not a good way of thinking. If we can see your mistakes, we're going to know how to help you better. Okay, let's go to number 14. So let's erase this part here. Okay, number 14 is the Fresh and Green Company has a savings plan for its employees. If an employee makes an initial contribution, well, there's the word initial, so we know that's our beginning amount, and the company pays 8%, okay, that's my rate, but it's in percent form, so let's fix it. Divide by 100, so our rate is actually 0.08. Here comes the other keywords, compound it quarterly, compound interest. So that means n equals, this tells us two things, n equals 4, and that we're going to use compound interest. Okay? I didn't finish this problem on here. Okay, well, let's write out an equation for this now that we know. Y equals 1,000, 1 plus 0.08 divided by 4, and then it's 4t. Until someone comes along and tells us what t is, this is the answer. And I should have written that in there, and I'll probably retype it. But if you have I already put in for copies for this. So make sure I will add this to this, write an equation. So if you weren't sure what to do with this, that's my fault. Okay, let's go to our extra credit. So that's the test. Not too bad if you've done your work. Impossible if you haven't been paying attention or watching the videos or doing your homework. Okay, the extra credit. It says, Brenda deposits money into a bank account that compounds. There's our key word. This is a hard one. Here's our rate. This is a little backwards from what we've been doing. She deposits $100 to begin with. That's our begin. We know this is a compound interest. Now we're asking a different question. In this case, we're asking when will she be at 150? That's our Y. That's our final amount. So let's look at our compound. So that's that. Monthly means n equals 12. This means I have to use compound interest. Here's my rate. It is not in decimal form. It still has a percent on it. So fix it. You have to still divide it by 100. So that's going to be point, now watch yourself, 0.00876. Be careful with that. And our original amount, our principal to begin with, was 100. What we're looking for is t. I'm going to give you a hint how to do this. I'm not going to do the whole thing. 150 equals, no, I should do the whole thing. P is 100. 1 plus the rate, which is 0.00876 over 12. because it's compounded that many times. And then 12t. So now we're trying to figure out t. Well, let's simplify this as much as we can. Okay, so now we have 100 out here, and then 0.00876 divided by 12, and then add that, oh, this is ugly, to 1. Nice. It gets to 1.00073 into the 12t. Still can't quite do much with this. I'm going to divide both sides by 100 because I can do that, because that's what's going on here. So now the simplest I can get this to is 1.5 equals 1.0073 to the 12t. Okay, I'm just going to make a table. And I'm going to start, we're trying to get this to equal 1.5. We need this over here. Let's make this, so we're trying to look for a time. So I'm going to start with just 1 year and see what happens after 1 year. So I'm going to parenthesis 1.0073, close parenthesis, and then 12 to the 12 times 1 is just 12. So that's, oops, I need to raise to the 12th power. So I'm just kind of messing around with this. I'm going to go 1.0073, close parenthesis, raised to the 12th power. I just want to see what happens after 1 year. After 1, we get 1.09. Okay, well that's not close to 1.5, but I don't know how far away it is. So let's put 5 in there and see what happens with 5. Do we go over the 1.5? This is what we're aiming at here. I'm trying to get to this. I'm trying for this to be that. And I can't tell how far away I am. So I'm going to put the same thing in, 1.0073 raised to the 12 times 5 power, where 12 times 5 is 60. Whoa, I'm almost there. I'm a little bit over, 1.54. I went a little bit too high. So I'm going to do this just to show you what I'm doing. I'm going to bring 5 down here. 1.54 was, so 5 was too high. I went over 1.5, but it's really not that much over. So I bet if I put a 4 in there, so parenthesis 1.0073 raised to 12 times 4. Well, 12 times 4 is 48, so I'm going to raise it to the 48th power. That's 1.4. So somewhere between year 4 and year 5, we get to $150. So you're going to have to do something like this with a table, and you're going to answer with between year 4 and 5. And that'll get you your extra credit points. You're going to at least have to try these, so you might as well look at this. Do not turn in your review packet without this done. I'm not going to give you full credit. I'll make you go back and redo it if you want full credit. Okay, so you might want to write this stuff down, pause it. This is kind of how you're going to do it. You might want to add this to your cheat sheet so you kind of have an idea how to do a problem like this. All right, let me move this stuff that's in the way of our next problem. Our next problem, a car once driven off the lot begins to decrease in value. Okay, well look, let's fill in these parts that we know here. This is Y. This is our beginning amount. So this is our A. 1 minus, this is our rate. And then we don't know T. Okay, now we know our parts, but go back. This is what type now. If it's decreasing in value, this is decay problem. What is our original amount? What does A equal in this problem? The original amount of this car was what it was driven off the lot. That's our A, so that's right here. So A equals $23,000. That's how much that car originally cost. What does this tell us it will be worth after 5 years? Okay, well now they told us T, so we're going to go Y equals 23,000, 1 minus 0.15. This isn't that hard. All of you should be able to do this because this was part of the chapter. Okay, it's not easy, but it's not a new concept. I shouldn't say it's not that hard. That's rude. But it's a concept that we taught you. So it's not a reach to get this one right. So do 23,000 parenthesis 1 minus 0.15 because it was already in decimal form in our equation. And all we're going to do is raise it to the 5th power. So after 5 years, our car will be worth about $10,205.22. And we kind of talked about this in class, how much cars depreciate. Of course, then we talked about if they become antiques, they start to appreciate, which is a weird situation, but it depends on the year when it starts to do that. Now, there's one more thing. According to the model, when it says according to the model, it's referring back to the original equation, which we already assigned our letters to, right? What is the percent of decrease each year? Well, we know our rate, because we picked it out of the equation, is 0.15. But this is asking for percent of decrease. Well, in order to get there, we divide it by 100%. If I want to change it back to a percent, we're going to times by 100%. So our rate in percent form is 15%. And then you have to explain it somehow. Well, doing this will help explain it. You need to say something like R in the equation is 0.15. I needed to multiply by 100 to get it back to 100%. So we have a 15% decrease each year. Okay, that's the review packet. That's the test. This is exactly what the test is going to look like, different numbers. So hopefully you spent the time on this. If you need help, let me know.